Okay, I just didn't want to say combine all the topics in one session. Uh, I wanted to segregate that basic theorem separate session and means I wanted to separate, not segregate. I wanted to separate the basic theorems. So I wanted to conduct basic theorems in one session and RL response in one session. Now this is RC response. Okay, so I will start the response, RC response session now. So RC circuit, DC response and solution using Laplace transformation method. Okay, so same pattern will not change, same pattern. So here there is an R and C circuit, R and C connected in series across a DC voltage source and a switch. So because of this DC voltage source of V of t, which is the excitation, response in the circuit is I of t. So initially capacitor is uncharged. Capacitor is initially uncharged. So voltage across the capacitor as soon as switch closes is 0. That is Vc of t is 0. Okay, as soon as switch closes, Vc of t is 0 here. So this is it, RC circuit. If you want, you can draw it. Okay. Now, switch, as soon as you close the switch, what will happen? Current will flow, okay, isn't it? Now, let us initially apply the Kirchhoff's voltage law to the given circuit. So V of t is equal to R into I of t plus voltage across the capacitor is what? Vc of t. Okay, so V of t is equal to R into I of t plus Vc of t. Consider it as equation 1. Now, what is the current in the capacitor? Current in the capacitor is C into d by dt of Vc of t. Current in the capacitor is, consider it as equation number 2. Current in the capacitor is, okay, I of t equal to C into d by dt of Vc of t. Now substitute this 2 in 1. Substitute the current. We know why we are considering this current equation of capacitor and substituting it in 1. Why? Because whatever current flows through the capacitor, same current will flow through the resistor. Okay, so that's the reason. So instead of I of t, you can write this expression. So what will happen? Equation will be modified as V of t is equal to R into C d by dt of Vc of t plus Vc of t. Consider it as equation number 3. If you are copying the equations, copy down quickly. So simply what we have done is, we have applied Kirchhoff's voltage law to the given circuit. After applying KVL, we have written KVL equation. What is our KVL equation? That is equation number 1. V of t is equal to R into I of t plus Vc of t. And current through capacitor formula is what? I of t is equal to C into d by dt of Vc of t. So same current flows through the capacitor and the resistor because resistor and capacitor are connected in series. Therefore, we have substituted the current capacitor current in the equation 1. Okay, so V of t is equal to R into, instead of I of t, C into d by dt of Vc of t plus Vc of t is our equation 3. Now let us apply Laplace transformation to the above equations. By taking Laplace transform of the above equation, V of t will become V by S, RC is constant, d by dt of Vc of t, isn't it? This is d by dt of Vc of t. Laplace of that, you will get S Vc of S minus Vc of 0 plus Vc of S. Okay, so Vc of t will become Vc of S. Okay, so this is it. Now we know as soon as switch closes at t equals 0, switch closes. Immediately after closing the switch, the voltage developed across the capacitor will be 0. Immediately voltage will not develop across the capacitor. So Vc of 0 plus value is how much? Is 0. So you just substitute that in this. This is 0. So what will happen to the above equation? V by S is equal to RC yes Vc of s plus Vc of s. Okay, so in that you can take Vc of s common. If you take Vc of s common in this equation, what will happen? Vc of s into 1 plus s Rc you will get. So V by s is equal to Vc of s into 1 plus s Rc. So you can write it down if you are copying it down. So I hope you are able to follow. So I could see many good morning messages in this session, but messages are more than the concurrent viewers. I don't know why. Okay, so good morning messages are many, but viewers are less. So if you have no interest in attending the session, what can I do? Your interest, your session. Okay, simply wastage of my time. Okay then. So V by S is equal to Vc of S into 1 plus S Rc we have got. Now from that we can determine Vc of S. What is Vc of S? Vc of S is what? Just modify the equation. Above equation you will get V by S by S Rc plus 1. So simply blindly if you are just listening to the session, watching the session, then it is of no use. You have to write simultaneously in order to follow the concept. So if you write, you will be able to follow. Okay, so Vc of s equal to V by S by S Rc of S plus 1 you will get. From this you can take Rc common. So if you take Rc common you will get S plus 1 by Rc. Okay, Rc into S plus 1 by Rc you will get. So our modified expression is what? Vc of s is equal to V by S by Rc into S plus 1 by Rc. You can interchange the positions of this S and Rc. If you interchange you will get Vc of s equal to V by Rc by S into S plus 1 by Rc. Consider it as equation 4. Now we can go for partial fractions. If you are writing it down, write it quickly. I hope we might have written. Now let's go for partial fractions. You will have A by S plus B by S plus 1 by Rc. So this is it. By using partial fraction, Vc of s equal to what? V by Rc by S into S plus 1 by Rc. That is equal to what? A by S, this term, plus B by S plus 1 by Rc. Let's determine A value. So what is our term? V by Rc by S plus S into S plus 1 by Rc whole divided by denominator of A is S. So S cancel at what? At S equal to 0. At S is equal to 0. Denominator equal to 0. So S cancel. What is left over? V by Rc by S plus 1 by Rc at S equal to 0 is left over. So substitute S equal to 0 in this expression. You will get V by Rc by 0 plus 1 by Rc. V by Rc by 1 by Rc. Rc cancel, left over is V. So A is equal to V. Consider it as equation number 5. So you have got the A value, that is V. So see, I have written each and every step here. I didn't skip even a single step. I have spent enough time to write these equations. Okay. So you can even modify, you can change the brackets now itself. See, brackets are not satisfactory. So I will just modify one bracket here. Brackets are not satisfactory. send it inside this, and I want to modify one more bracket. This is it. I have modified one bracket at least. So we can't do the modifications now. Earlier the thing is, write the equations in one system, and I use some other system for taking the session. So the software will be different. I can increase this font size so that it will be more easier. Just expand it. Try to keep it in one line. This is better. Difference is not there even if I have changed the brackets. There is no much difference between these brackets and these brackets. Okay, whatever. So A value is V. I hope you might have written. Meanwhile, I was simply just editing the equations. So similarly, we can determine B value. So B is equal to what? V by RC by S into S plus 1 by RC whole divided by S plus 1 by RC. I equate the denominator of B to 0. You will get S equal to minus 1 by RC. Okay, so at S equal to minus 1 by RC, and here you can cancel S plus 1 by RC with S plus 1 by RC. What is left over? V by RC by S at S equal to 1 by minus 1 by RC. Substitute S equal to minus 1 by RC here. So RC cancel. You will get minus V. V equal to minus V. So now we have determined the value of here. Give some notation 6 here. So for the previous RL case, I didn't give the notations, numbering. But here I have given. So okay, substitute 5 and 6 in your equation 4. Substitute A value and B value. So VC of S is equal to what? V by RC by S into S plus 1 by RC. That is equal to what? A value is V, B by S plus, B value is minus V. So minus V by S plus 1 by RC. Now we can go for inverse Laplace transformation. So I thought you people might be writing, that's why I just waited a bit. Now let us go for inverse Laplace transformation. So before going for inverse Laplace, what I have done, I have taken V common here. So V common I have taken, and I have written 1 by S minus 1 by S plus 1 by RC. So if we go for inverse Laplace, 1 by S is 1. Inverse Laplace of 1 by S. Inverse Laplace of 1 by S plus 1 by RC is e to the power of minus 1 by RC. Okay, formula is what? E power, I will write e power minus int. Laplace of e power minus at will give me 1 by S plus a. Okay, Laplace of e power minus at is equal to 1 by S plus a. Here S plus 1 by RC is there. Okay, so here minus of minus I must write. Okay, so minus of minus will give me minus 1 by RC. Okay, So that means Laplace of e power at is equal to 1 by s minus a. So you must know the formula, then only you will be able to follow. Otherwise, I'm confusing you people. Okay. So if I simply tell some equations of formulae, you won't be able to follow unless and until you already know the formulas. Okay. So Vc of s inverse Laplace is Vc of t. V is constant. 1 by s inverse Laplace is 1. 1 by s plus 1 by rc c power minus 1 by rc t. So this is our step response of RC circuit, Vc of t. Okay, so let us see the numerical problems. No one is in their session. Confident viewers are not there. No one is there in the session. Okay, now let us see a numerical problem. So in this numerical problem, they didn't give the circuit. They didn't give the circuit. So there is a DC voltage source of 20 volts applied to a series RC circuit having R equal to 12 ohms and C equal to 14 farad. You have to find the voltage and current after switch is closed at t equal to 0. Okay, so circuit is not given, you have to draw the circuit here. So 20 volts is the source and resistor value is 12 ohms and capacitance of 14 farad is given. So response I of t, let us assume at t equal to 0, switch is closed at t equal to 0. Okay, now apply KVL. If you apply KVL, what do you get? 20 equal to 12 into I of t, that is resistance R into I of t, plus voltage across the capacitor. I have written as I didn't write the formula, I have simply written Vc of t. Okay, so what is the current through the capacitor? I of t equal to C into d by dt of Vc of t. Whatever pattern that we have followed for theory, same pattern I am going to follow for the solving the numerical problems. So if any concurrent viewer is there, they can write it down. So I could see no one in the only one concurrent viewer. Someone has joined just now, it seems. No one is there. No concurrent viewers are there. It's good. Keep it up. It's good. It has been 20 minutes and 20. Okay. No concurrent viewers. Very good. Keep it up. Good mornings will be many. Good mornings. No concurrent viewers, but good mornings will be many. Okay. Many good mornings with no concurrent viewers. Okay. It seems I'm just wasting my time. I'm not teaching the subject. Okay, I'm not giving any useful session, what is a lecture of any useful topic. It's okay. So apply KVL, you will get this expression 20 equal to 12 into I of t plus Vc of t, and I of t is equal to what? C into dVc by dt. Substitute 2 in 1, what we have done in the theory, same thing you do. Okay, so if you do the same thing that we have done in the derivation, Same, you will get 20 equal to 12 into current value C into d by dt of Vc of t plus Vc of t. So now here 20 is equal to 12 into C value. C value we already know, that is 14, I think so, 14, isn't it? 14. Yeah, 14 into 12, you will get 168. D by dt of Vc of t plus Vc of t, considered as equation number 3. Okay. Now you can take the Laplace transformation for the above expression. So you will get 20 by s, 168 is constant, leave it as it is. D by dt of Vc of t, Laplace of this is s Vc of s minus Vc of 0 plus Vc of t, Laplace is Vc of s. Okay. Now we know at t equal to 0 switch is closed. So at t equal to 0 plus, that is immediately after closing the switch, the voltage developed across the capacitor. Voltage across the capacitor is 0. So Vc of 0 plus is 0. As soon as switch is closed, no voltage is developed across the capacitor. So voltage across the capacitor is 0. So Vc of 0 plus is 0. So substitute that condition here. You just consider it as 0. So what is left over? 20 by s, 68 Vc of s plus Vc of s. And if you take Vc of s common, you will get 1 plus 168s. Okay. So 20 by s equal to Vc of s into 1 plus 168s. So if anyone is writing it down, if any concurrent viewer, no one is there, of course. Okay. So if anyone is writing, you can write it down. It's good that I receive many good morning messages, but concurrent viewers, and it's okay. It's your wish. 20 by s is equal to Vc of s into 1 plus 168s. సిలబస్ కంప్లీట్ చేయాలి ఎగ్జామ్కి, అందుకని చెప్పాను.
ఏం సిలబస్ అది ఎన్నికాల్లో చెప్తున్నావా సిలబస్?
అక్కడ చాలా ఎక్కువ
చెప్పేది ఎవరి కోసం ఆపేది ఇక్కడ? ఎవరి కోసం ఆపేది?
Okay, then okay, Vc of s is equal to what? 20 by s by 168s plus 1. You can take 168 common. If you take 168 common, you will get s plus 1 by 168. So you can interchange the position of this s and 168. So Vc of s is equal to v by 168 by s into s plus 168. So if any concurrent viewer is there, you can just copy it down quickly.
సౌండ్
Okay, so now let us go for partial fractions. In the denominator you can see s into s plus 1 by 68 is there. Let's go for the partial fractions. So Vc of s is equal to what? A by s plus b by s plus 1 by 168. You can simplify this. I didn't simplify it. If you want, you can simplify it. So consider it as equation 4, and now let's determine a value. So write down the whole term divided by s at s equal to 0. So now s cancel. What is left over? 20 by 168 also you can simplify. I didn't simplify it, as I have left it as it is. Okay. So if you want, you can simplify. Now what is left over? 20 by 168 by s plus 1 by 168. Substitute s equal to 0. You will get 20 by 168 by 0 plus 1 by 168. 168 cancel. What is left over? 20. Okay. So a value is 20. So if anyone is watching, you can copy it down. Okay then. Now b value, b is equal to what? Our term equation, that is 20 by 168 by s into s plus 1 by 168 divided by the denominator of b is s plus 1 by 168. So you can cancel s plus 1 by 168, s plus 1 by 168 at s equal to minus 1 by 168. So v by so v is 20, isn't it? I have, sorry, I forgot. I simply copied from the previous slide and I forgot to write 20 here. I have written 20 charge. This is 20. No. So b value is b is equal to you will get this term cancel, substitute s equal to minus 1 by 168. If you substitute 168 cancel, you will get minus 20 answer. B equal to minus 20. Substitute this b value, a value in your equation 4, that is VC of s equation. So you will get 20 by s plus minus 20 by s plus 168. So after substituting, VC of s is this. Now this is VC of s. Now we can go for inverse Laplace transformation. So go for inverse Laplace transformation. 1 by s, inverse of 1 by s is 1. Inverse of 1 by s plus 1 by 168 is what? E power minus 1 by 168t. So VC of t is 20 into 1 minus e power minus 168t. So once again I am writing the formula for e power at Laplace. So Laplace of e power at is 1 by s minus a. So e power minus at means s plus a. That's it. So we have determined VC of t. Now let us determine the response. We didn't determine the response, isn't it? Let us determine the response from equation 2. What is I of t? I of t is equal to c into d by dt of Vc of t. C is 14. C 14 into d by dt of Vc of t. So what is Vc of t? Just now we have calculated 20 into 1 minus e power minus 1 by 168t. So instead of Vc of t, there is my cursor. Instead of Vc of t, write this. Okay. So 20 is constant, send it outside. D by dt of 1 minus e power minus 1 by 168t. Here I think something is missing. These equations, I will write it here. Okay, now I of t is what? 14 d by dt of Vc of t. Substitute Vc of t. Vc of t is what? 20 in 1 minus e power minus 1 by 168t. So I'll take the laser. Okay, so I of t equal 14 d by dt 20 into 1 minus e power minus 168t. So I of t 14, 20 is constant, so send it outside. D by dt of 1 minus e power minus 1 by 168t. So just differentiate 1, you will get 0, and differentiation of e power minus 1 by 168t is what? Minus 168t. Okay. What is it? Yeah, minus 168t into e to the power of minus 168t. Okay. So just you just simplify this, you will get I of t equal to minus 1.1666 e power minus 1 by 168t amperes. Okay, simple differentiation. I hope you know differentiation. So if you know the differentiation, you will be able to solve. Okay, this is it. So simply we have to differentiate the given terms and simplify it. You will get the response in time domain. So I hope, okay, whatever. So next one more session I will take today afternoon after 3 p.m. for RLC. Let's see. I can conclude now itself. It won't take more than half an hour, I think so. Shall I take RLC session now itself or today afternoon session? Whoever is there. I didn't understand this. Okay. Do you want me to take afternoon or now? It will take, I think, approximately half an hour. Within half an hour, I will conclude and no need to take one more session in the afternoon. What is this okay I have in the message? I didn't understand. No one's watching. Do you want me to continue or shall I take one more session in the afternoon? Just mention in the chat box. Is there anyone in the session? Okay, join the session in the afternoon. Okay. So I'll just you can fill the Google form. Fill the Google form and after filling, you just mention that you have filled and you can leave. afternoon session will not be for 1 hour. It will be less than 1 hour, maybe 30 to 40 minutes. That's it. Okay, I'm ending this session.